So, morning. Let's start Maxwell's fourth equation today. So, Maxwell's fourth equation is nothing but Faraday's law of electromagnetism. Faraday's law of electromagnetic induction. Right? So, in Faraday's law of electromagnetism, he actually connected electrostatics and magnetostatics. Both are interrelated. That's what, if there is a change in magnetic field, and EMF will get generated. EMF will get generated. So, E is proportional to what? Minus d phi by dt. This is basic law of Faraday's law of electromagnetic induction. We also know that voltage will be equal to E dot length. If we are having L length conductor which is having electromagnetic field, which is under the electromagnetic field electric field E, a voltage will appear between these 2 points such that E into L will be the voltage. So we can again be written as line integral of E dot dl. These two equations are the base equations for Maxwell's fourth equation. So V is equal to minus d phi by dt, as well as V equal to line integral of E dot dl. Right, let's start. That is first step of Faraday's law of equation we have written. Also we have written the second equation of voltage. Then let's go to the second equation, that is Gauss law for magnetism, which we have already studied. What is flux phi? Flux phi is equal to flux density into area, which can be written as surface integral of B dot ds equal to flux phi. Next, we can integrate these two things. We know what is the value of flux by using the equation. So this equation we have to substitute over here. So V will be equal to what? Minus d by dt. Instead of phi, we should write surface integral of B dot ds equal to line integral of E dot dl. We already know, right? Then what do you have get? Put this integral outside, put the t by dt inside, it will become dou by dou t. So minus of surface integral of dou b by dou t into ds equal to line integral of E dot ds. This is the integral form of Maxwell's fourth equation. That is written over here, line integral. See, over here we are having an E as well as B. So what is E stands for? E is related to voltage or electrostatics, I would say. B is what? Magnetic field density. So magnetostatics. So this is how magnetostatics is related to electrostatics, right? Then we'll go to point form. So this is the equation we have earlier obtained, line integral of E dot dl equal to minus surface integral of dou b by dou t ds. But according to Stokes theorem, what we know, line integral of A dot dl will be equal to surface integral of del cross A ds. Surface integral, line integral. So line integral and surface integral are connected. So this can be used over here, like line integral of E dot dl can be written as surface integral of del cross E ds. Now this is in surface, this is also in surface. So this term minus dou b by dou t will become equal to del cross E. So del cross E equal to minus dou b by dou t. That is a differential form or point form of Maxwell's fourth equation. So we can conclude this is the integral form, this is the differential form. So in Faraday's law we are relating electrostatics as well as magnetostatics using these two equations. So we have completed all the four laws. So our different four laws are written in this form. First law we will call it as Amperes law, and that too is not just Amperes law, it's modified Amperes law. What we did it, we included displacement current density also with that of normal current density. Ordinary Amperes equation is like this: line integral of H dot dl is equal to total current enclosed is equal to surface integral of J dot ds. To that J we have added dou d by dou t, which is the JD. So line integral h dot dl equal to surface integral j plus dou d by dou t ds is the integral form of Amperes law. In point form, we will write this line integral. We apply Stokes theorem. So we will get surface integral of del cross h ds. So del cross j equal to, this is also a surface integral, that is j plus dou d by dou t. We have studied. Just before we have studied Faraday's law, that is line integral of E dot dl equal to surface integral minus dou b by dou t ds. Applying Stokes theorem over here, we get del cross E, surface integral of del cross E. So we can equate del cross E and minus dou b by dou t. Then Gauss law for electrostatics is, we know that Q equal to psi, and Q can be written as surface integral of d dot ds. Psi can be written as volume integral of rho v dv. So applying divergence theorem, we will get del dot d equal to rho v. So Gauss law of magnetostatics is surface integral of b dot ds equal to 0. And applying divergence theorem over here, we will get del dot b equal to 0. So these two equations, so sets of equations, integral form and point form, are the Maxwell's equation. Study thoroughly. All these four equations are very important. It's a very important questions for the university exam also. Without a Maxwell's equation, there won't be any question paper on electromagnetism. So study well. Thank you.